Now I want to talk about who we are and where we really came from. The universe was brought into being by creating rules and the framework for it to organize itself. First, dark energy, the raw material from which everything would arise. Second, dark matter, congealing of dark energy, which could be manipulated to create a shadow reality. According to the rules designed by the creator, when dark energy and dark matter combined in the appropriate fashion, there was an almost catalytic reaction which produced Higgs bosons, which would later be called God particles. And when they interacted with dark matter and energy in the appropriate ratios and collisions occurred, subatomic particles called quarks, neutrinos, mesons, and gluons, plus a few others unnamed, combined into appropriate ratios and formed larger subatomic particles named electrons and positrons and protons, which grew from the positrons combined appropriately with dark matter and energy, while fusions under great heat and pressure created by interactions of dark matter and dark energy produced particles named neutrons by those who felt it their business to name such things later on. When electrons and positrons encountered one another, the result was the production of particles with wave-like properties, which were photons, and these resulted in a form of matter energy called light at the behest of a directive which the creator willed, which might just as well be described as let there be light. So this was a much more complex process of interaction than has previously been delineated, but still followed the procedural framework described above. This process has also been called the Big Bang. So let's say what happened with the Big Bang and where things went from there. The particles were organized into atoms, and slowly some became molecules. The atoms were some which we see in the periodic table, and some which haven't made it this far from the center yet, but those who did make it were as listed in our periodic table, with hydrogen, helium, etc., as listed. Carbon was the atom which became the element of life, especially when combined with hydrogen to produce so-called hydrocarbons. Carbon combined to other carbons, to hydrogen, to oxygen, to nitrogen, and to sulfur, and phosphorus compounds. In the process, it can form nucleic acids, proteins, phospholipids, fats, steroid hormones, and carbohydrates, and many other intermediary compounds. Other elements form the material of stars and planets, which coalesce into galaxies and galactic clusters. The swirling elements, whether in the form of gases, liquids, or solids, gained energy and momentum due to the interaction of gravitational forces. Suns with differing spectra and differing gravitational fields formed and positioned themselves based on those fields, and galaxies took shape and positioned themselves based on the same force differentials. There are estimated to be around 600 billion or so galaxies in the known universe without interjecting quantum realities, though, of course, if we interject Schrodinger's cat into the mix, the numbers become incalculable. But the universe we know is still the one we are in and is an incredibly beautiful creation. We need to explain our existence, so we will move to one spiral galaxy and look at one small arm where a dwarf yellow star is located. We will then look at a very hot collection of what is called cosmic dust as it coalesces into a churning solid ball, and slowly, with proper collection of elements, it becomes the very beginning of the planet, which self-aware inhabitants would call Earth, or terra firma later on. After all the condensing and congealing of cosmic dust had taken place, gravitational forces and other attractions caused the cloud, which was the third from the yellow star in that spiral galactic arm, to condense into a ball of rock, which cooled enough eventually to form a core of molten metal, which acquired a granite, quartz, basaltic, and other igneous and metamorphic rock coating, with liquid water cooling enough to layer in between some of the layers of denser materials, and then to finally layer atop the molten surface, helping it to solidify, while the water itself was a boiling maelstrom and dissolved some of the minerals as it surged and tumbled, eventually becoming that which we referred to as primordial soup. There were atoms, molecules, and macromolecules in the soup, and they swirled, churned, and bubbled along with the water, which caused atoms, molecules, and macromolecules to careen about and bump into one another, in some cases producing new molecules, until some of the combinations produced adenosine triphosphate, uridine triphosphate, cytidine triphosphate, and guanine triphosphate, which were in the heated, almost boiling water able to join together to form strands of ribonucleic acid, which we call RNA, which is able to act as its own catalytic enzyme. They call them ribozymes. The RNA molecules were single-stranded alpha helices, which spent the next 100 or so million years replicating themselves and using the heat of the water in the Earth's crust to fuel this duplicative activity until the water in all its locations which were interconnected was teeming with literally billions of these strands of RNA comprising the RNA world theorized to have existed before the appearance of the first protocell. The next step of the development of the life required some major solar flare emissions, which sent X-rays, gamma rays, and shortwave ultraviolet rays through the primitive atmosphere, which is mostly composed of methane, ammonia, and nitrogen, with a few other gases of various identities. But the atmosphere was such an acidic and reductive composition that there was no possibility yet of free oxygen existing. The highly active bombardment by the rays mentioned above altered many of the uridine molecules and uridine triphosphate molecules by methylation to 6-carbon in the pyrimidine ring, and with the simple methylation step, uridine was converted to thymine, and the ribose sugar was in some instances converted to deoxyribose, and the stability of the resulting helix allowed for it to bind with a complementary strand of the same nucleic acid to form the double helical structure called deoxyribonucleic acid, or DNA. The oceans were still hot, but by splitting the double helices under certain circumstances and hybridization of some of the catalytic strands of RNA, the DNA strands were duplicated and double-stranded DNA began to be found in fairly high concentrations in certain locations, having a special affinity, it seems, for clay particles along the shorelines. Along these shorelines also accumulated globs of phospholipid, and there began to be seen a theme of emergent properties as phospholipid layers formed small micelles, some of which surrounded the DNA double helices. Millions of years passed, and the Earth's surface cooled a bit more, as proteins were made from some of the amino acids, which were then used as building blocks by RNA molecules over the millennia. Once the proteins were produced, they assumed all manner of shapes and configurations, and some of these were found to enable DNA to direct RNA to make other proteins, as well as to put together an amino substituted carbohydrate polymer, which we now call peptidoglycan, which was able to layer around some of the protocells to become the first true cellular bacteria. From these first true bacteria arose all of the diverse forms of life which we see in existence today. I'll talk about the bacteria and more things in the next video.